Hi everyone, I'm Dishant and we are going to discuss the basics of acid-base disorders. There are three methods of quantifying acid-base disorders. The first one and the most commonly being used is the physiological approach. It uses the Henderson-Hasselbalch equation. There are two other methods which are base excess approach and physicochemical approach. We are not going to talk about them today. Okay, so for the physiological approach, there are a couple of things that we need to understand. The first one is pH, bicarb, and PaCO2. So even before we start talking about it, it is important to know about the normal ranges. So the normal range of pH in blood is 7.35 to 7.45. Bicarb in millimole per liters, a normal range is 22 to 26, and PaCO2 millimeters per mercury, 38 to 42. Okay, acidemia. So what is acidemia? It is low blood pH. Alkalemia is high blood pH. Now how is acidemia different from acidosis? So in case of acidosis, we are talking about the process that would lower the pH. Here it's just like numerical value of lower pH. Similarly, for alkalosis, we are using the process that would increase the pH. And just for the simplicity of the concept that we are going to understand, we just need to consider PaCO2 to be acidic and bicarb to be basic. We are not going to go in the chemical details about these things, but let's just remember this. Okay, so there are four basic disorders: respiratory acidosis, respiratory alkalosis, metabolic acidosis, metabolic alkalosis. We are going to talk about each of these later. But in case of a respiratory disorder, the process is a change in PaCO2. So respiratory, which is carbon dioxide is excreted from lungs, and that's why the change in PaCO2 will be respiratory disorder. And in case of a respiratory disorder, the compensation would be a change in bicarb. Now, who will help us make this change? And in other words, what are the buffers? So in case of acute respiratory disorder, the buffer is intracellular, and in case of chronic respiratory disorder, the buffer is renal or kidneys. In case of a metabolic disorder, the primary change is in case of bicarb, which again is controlled by kidneys, and the compensation is a change in PaCO2. Therefore, the buffer in this case would be respiratory. So whenever we are talking about acid-base disorders, it is always good to follow a stepwise approach. So first we'll talk about history and physical exam, followed by pH, followed by primary acid-base disorder, secondary response, and presence of a mixed acid-base disorder. So history and physical exam. So there are so many hints in history and physical exam that would help us. So in case of an infection, for example, if there is an infection, then we would think that it could be a possible sepsis, and that's why it could be metabolic acidosis. In case of, for example, opioid use, opioid would decrease the respiratory drive and rate, therefore it would cause CO2 retention and thereby cause respiratory acidosis. So pH, the normal ranges, as we talked, is 7.34 and 7.4 to 7.45. I'm sorry, 7.35 to 7.45. So anything lesser than 7.35 would be acidemia, and more than 7.45 would be alkalemia. So what is the formula for pH? It is 6.1 plus log of bicarb upon 0.03 times PaCO2. Now these are a couple of constants which we don't need to delve into, but what we need to understand from this is, in order for pH to remain constant, bicarb and PaCO2 are inversely proportional to each other, which means if we want the pH to remain constant, then if bicarb increases, then the CO2 will also have to increase to balance the effect, and vice versa. So now we are going to talk about primary disorders. So how do we determine primary disorders? So first we look at the pH. What is the pH? So if it is less than 7.35, as we just talked about it, it's going to be acidemia. Now, what is the process or the mechanism that causes acidemia? Is it bicarb or PaCO2? So if it's bicarb, then it's going to be metabolic acidosis. And remember, bicarb is basic, so it will have to be lower than the normal range, and PaCO2 is acidic, so in case of acidemia it has to be on the higher side, and if the PaCO2 is the reason, then it is respiratory acidosis. Similar is the case with alkalemia, and I don't need to go through the details because it's just a replica of whatever we talked about. pH, so whenever the pH is between 7.35 to 7.45, so what we would think is, okay, there's no disorder present. But then there is a possibility that in case a mixed acid-base disorder may be present, which we might miss. So even when we have a normal pH, it is important to look at all three: bicarb, PaCO2, and anion gap. If all three are normal, then that means that there is no disorder present. If all three are not normal, then there is a mixed acid-base disorder present, which we'll talk about later. These are the references, and thank you so much. Please leave your questions and feedback in the comment section below.